At the end of the last video, we were looking at intervals of increase or decrease for this function, and we realized that if we just look at the intervals of increase and decrease, we can get an idea of where the maximums and minimums happen. And that is the first derivative test for determining where maximums and minimums happen. Oops. Of the first derivative test is to find the maximums and minimums, and we're going to start it the same way we start finding intervals of increase or decrease. We're going to take the derivative and set that equal to 0. Or undefined, but there is, for this particular example, there's no place where this derivative is undefined. So cosine is equal to 1/2 at x equals pi over 3 and 5 pi over 3. Because our interval is from 0 to 2 pi, so we have to get both of those places. Okay. Then we're going to look at our first derivative number line. We're going to start at 0 and end at 2 pi because this has endpoints. And then we'll look at pi over 3 and 5 pi over 3. And then I'm going to do a little sketch of the unit circle so that I can think about signs here. 1/2 minus cosine. So cosine is larger than 1/2 because remember cosine is the x-coordinate. It's larger than 1/2 up until we get to pi over 3. So 1/2 minus cosine would be negative. And then cosine is smaller than 1/2 until we get back over here to 5 pi over 3. So this part would be positive because we're subtracting less than 1/2. And then on the end, we'd again be negative because cosine would be larger than 1/2. So before I even plug any values in, I know, this is the first derivative test, there's a sign change from negative to positive at pi over 3. Because of that sign change, I know that there is a minimum value at pi over 3. And then again, this function is increasing until 5 pi over 3, so I know that there's a maximum value on f at 5 pi over 3. And then we're coming down to an endpoint here, so a minimum value is going to happen at 2 pi, and a maximum value would happen at 0 because the function is decreasing after that. So the first derivative test, I haven't plugged any numbers in, but I know for certain that there will be a minimum at pi over 3, a maximum at 5 pi over 3, a maximum at 0, and a minimum at 2 pi. First derivative test doesn't tell us which is the absolute maximum and which is the absolute minimum, but the first derivative test gives us an idea of which would be maxes and which would be minimums. To figure out whether it's an absolute or a local, that's when we plug our values into our function so that we can figure that out. So when we do this, when we're making a table of values, we're not interested in the value of the derivative. In fact, we know it will be 0 at these two places. We're interested in the value of the function. We want to know the y coordinates at this point. So this y coordinate would be 0. This would be 1/2 of pi over 3. So pi over 6 minus sine of pi over 3. That would be root 3 over 2. And 5 pi over 3 would be 5 pi over 6 minus sine of 5 pi over 3 would be negative, so 3 over 2. And then 2 pi would be 0, it'd be pi. Okay, so without a calculator, I wouldn't be confident of this, that this value is larger than pi, but because I've done the sign chart, I know that there's a maximum at 5 pi over 6 plus root 3 over 2. I know that's a maximum value. And I also know that that's larger than the other maximum value, which is 0. It's not immediately obvious to me that this is a negative value, but it is clear if I start thinking about numbers. This is about 1/2, and this is over, this is bigger than a half because it's 1 point something over 2. So we can tell by looking at the first derivative that we have a maximum. If I need to justify that those are maximum values without looking at the y-coordinates, if I need to say there is f of pi over 3 is a minimum, the wording for that is because f prime changes from negative to positive at x equals pi over 3. So I'm using the sign change to justify that I have a minimum value. I'm looking at the derivative to justify a conclusion about f. F prime is helping me decide about f. I would write a similar sentence for 5 pi over 3. F of 5 pi over 3 is a maximum because f prime changes from positive to negative at 5 pi over 3. And then the endpoints, there's a, f of 0 is a maximum because f prime is negative for x is greater than 0 and 0 is an endpoint. So that kind of justification of using the first derivative in order to determine where your maximums and minimums happen, that's the first derivative test. Okay, we're going to do one more. Here is a different function. So we're going to take the derivative. And then not forgetting the chain rule. Then this is one of those ones where I really think it makes sense to rewrite it so you have positive exponents back. And if I look at where that's equal to 0, the numerator is equal to 0 at x equals 0. And if I look at when that does not exist, that would be when the denominator is equal to 0, or when x squared minus 4 is equal to 0, or at x equals 2 and x equals negative 2. So now if I grab my number line, I'm going to put negative 2, 0, and 2 on my number line and look at the sign chart for f prime. So f prime, if I put a number that's way negative, beyond negative 2, my numerator would be negative. I square it, I'm going to get a large number. Minus 4 would be positive number. Cube root of that would be positive. So beyond negative 2, f prime is negative. And then if I choose a number between 0 and negative 2, my numerator is still negative, but now so is my denominator, because if I square it and subtract 4 and then take the cube root, I would have a negative value. So a negative divided by a negative would be a positive. I don't want you to assume that sign charts always alternate, but this one does. If you continue with that process of figuring out the signs on f prime, your sign chart always will alternate for this function. It doesn't always. Okay, so now I know that there is a minimum value at x equals negative 2 because f prime is negative before negative 2 and positive after negative 2. So to justify that, I would say f of negative 2, which just if I plug that in would be 0, is a minimum because f prime changes from negative to positive at x equals negative 2. And then same kind of sentence for 0, f of 0, which is the third root of 16, is a maximum because f prime changes from positive to negative at x equals 0. I'm not going to write all of them out, but it's the same kind of sentence. X equals 2 would be a minimum, or f of 2 would be a minimum because f prime changes from negative to positive there. This justification of extreme values is, it's kind of a sentence that is a boilerplate sentence. Like you always write it the same way. You always talk about why your function has a minimum. It's because your derivative changes from negative to positive. And so that's what the first derivative test says, if you want the words. If f prime changes sign from positive to negative, then f of c is a maximum. This is the language that you're going to use to justify a minimum or a maximum value. If f prime changes from negative to positive, then you have a minimum value. And then you've got your endpoints too. So at an endpoint, so at A, which is the endpoint, then you have a minimum because you've got your function is increasing after that endpoint. And if your function, your f prime is positive at that endpoint, then you're at the other end, then you have a maximum value because you're increasing up to that endpoint. When you're writing your justifications using the first derivative test, really try to avoid the words the function, it, the graph, the equation, the derivative, when you're talking about f of x or f prime. Be really careful to avoid those words because f is a function, but so is f prime. F is a function, but so is f prime. F prime is a derivative, but a derivative of what? F is a derivative of something, probably. So you have to be very, very clear and specific as you're talking. So really try to avoid those words in your justification and use these words instead. Name the function. So if you're trying to say f has a maximum value, then say f has a maximum value, not the function has a maximum value. And the other word of warning about these justifications is that sometimes people say f has a maximum value because f prime changes from increasing to decreasing. And it's not that f prime changes from increasing to decreasing. It's that f prime changes from positive to negative. F changes from increasing to decreasing, and you could use that as a justification, and that's not just a variation on the first derivative test. That wording is acceptable, but make sure you're very clear about which function you're talking about is increasing or decreasing or is positive or is negative, and just use that boilerplate language really. F has a maximum value at x equals 2 because f prime changes from positive to negative at x equals 2. Be really clear about what you're talking about. All right, that is the first derivative test.